Well, now we've shown you two ways that a sensor can fail the DAR test. We had ship 427 go out of service and they changed the #1 skew sensor to fix it. I've got that skew sensor here today and I've got it hooked up with a little harness, and it failed a different way. A flat position sensor has the excitation voltage shaded onto the third leg of the synchros. So typically when you hook into the first wire, any of the synchros, you will see it fail if it's going to fail. Some legs will fail more than others, but typically you'll see it. When you're running on the skew sensor, the excitation voltage is independent. And let me show you what I'm talking about. Now, here we've got it hooked up to one of the synchro windings. Turn it on to the insulation test. It's in 500 volts. We want to hit the DAR test, and we're hooked into one of the windings. We hit go, and this is what a good test looks like. If you have it set to 500 volts, it'll test up to 110% of that in mega ohms. So you'll see 550 mega ohms. I can already tell this is a good test. You'll see that the lightning bolt over here is telling you that the test is still running, and this one is going to come up with an error message, meaning that the DAR is so high I can't even measure it. Now watch this. I'm going to reconnect this to the excitation winding. Watch this. Bang, 2.5 mega ohms. Anything less than 20 mega ohms is a failure. This one is going to fail both the resistance and the DAR. But it's important to note that on the skew sensor, the excitation windings are independent and is not shading the synchro windings. And this will cause a problem with the lockout. Now what's peculiar about this one is that it didn't lock out. The flaps just wouldn't move. That's a new one on me. And there's 1.2 on the DAR. So it's marginal. And if you run this test again, you might get 1.1. I haven't seen anything higher than 1.2.